วัสดีครับ In this script we will discuss the solution of test number 9. Again we are talking about the motion in two dimensions. In this case it is a motion in two dimensions under the gravitational acceleration only, which is one of the famous kind of motion, and all physics students must study this kind of motion, which is a projectile motion. Okay. Anyway, as we have discussed before, for the 2 or 3 dimension, if we use the rectangular coordinate to describe the motion, we can describe the motion separately. I mean, the motion along the x-axis and the motion along the y-axis, we can describe it separately, and we will use that technique here also. In this problem, the question is: a rock is thrown upward from the level ground in such a way that the maximum height of its flight is equal to its horizontal length. At what angle is the rock thrown? Okay, so it means that we have the situation that a rock moves in the projectile trajectory because it moves freely under the gravitational acceleration, and we found that its maximum height h is equal to its length. Okay, h equal to r, and what we want to know is the initial angle that the rock is thrown. Okay. So it means that we have to analyze what is the value of h and what is the value of r, and how can it depend on the angle theta, and then we equate h equal to r to calculate the theta. You can see that to calculate h, we have to analyze the motion in the vertical direction, and to calculate r, we have to analyze the motion in the horizontal direction. We can analyze these two motions separately, and then we bring it back to this condition that s equal to r. Okay. So let's start with the horizontal motion. We first dissolve the initial velocity v into the two components of vx, vx0 and vy0. This is v0. Okay, and then we analyze the motion separately along the vertical and horizontal direction. Start with the vertical direction. We can calculate the maximum height of the motion by using, because we know that the acceleration of the object is a constant which is equal to the gravitational acceleration. So we can use the equation of motion for the constant acceleration to do this calculation. And we can use v squared equal to v0 squared plus 2ay minus y0 here, because we know the acceleration is a constant. Okay, and to calculate h, we don't care about time, we just want to know the distance h. Okay, so at the highest position, we know that at h v equal to 0, right? Vy equal to 0. So we have at the highest position, the object will not move further in the vertical direction because that is the highest position. Okay, so we have Vy equal to 0, and we can write 0 is equal to Vy 0 square plus 2 minus g. In this case, we take the upward direction as a positive direction, so g is equal to the gravitational acceleration is equal to minus g. The minus means the direction of the acceleration point down. And y minus y0, we can take y0 equal to 0 at the original point, at the initial point. So y minus y0 is h. Okay, so this is h, which means we have h is equal to Vy0 square over 2g. Okay, but we also know that Vy0 is equal to V0 sine theta. This is the way we resolve the component of the vector. Okay, so we have the relation between h and theta, okay, through this Vy0. Okay, but we don't know the angle theta yet. Now let's move to the horizontal motion. We want to calculate r, the length of the motion. And how can we calculate r? We can say that r is equal to Vx0 times t, where t here is the time of flight, the total time of flight. The total time of flight is the total time from the starting point to the end point of the motion. This is the total time of flight. T is the total time of flight. Okay. And how can we calculate the time of flight? This is interesting. If we want to calculate the time of flight, we have to calculate the total time of the motion in the vertical direction. Why? Because the object will stop when it hits the ground again, and it will hit the ground because the motion in the vertical direction. The motion in the horizontal direction will keep the object move forever. Okay, because there is no acceleration in the horizontal direction, so the particle will move in a constant velocity forever in the horizontal direction. But in the vertical direction, eventually the object will come back to the ground, and that moment that the object stops. So we have to go back to the vertical motion to calculate the time of flight. Okay. And you can see that the time of flight here can be calculated from the equation y equal y0 plus Vy0t plus half of at squared. Okay, and we know that Vy0 is 0. This is the initial position, and we know that at the end the object comes back to the same vertical position. Okay, so it means that y is equal to 0 also. So we have that 0 is equal to Vy vy0t plus half of at squared, or we have t is equal to minus 2y0 vy0 over a, right? If we move, if we divide both sides with t, okay, we have vy0 here and we have half of at, okay, and then we move vy0 to the left side, which is, we get minus vy0. We have minus vy0 and then divided by half of a, so we get this value, and we have this as 2vy0 over g, because we use a equal to minus g, right? Or we have this is 2 v0 sine theta over g. Okay, so we have the time of flight now, 2v0 sine theta g. Okay, go back to the range. Okay, go back to the, we use t equal to 2v0 sine theta g, and we use v0x as a v0 cos theta. Okay, so we have here as a 2v0 square cos theta sine theta over g. This is the range of the motion. Okay. Now we put all of our calculations together. We have r equal to h, which means that we have 2, which means that we have the 2v0 square cos theta sine theta over g is equal to h. We have h equal to vy0 square over 2g. So we have vy0 is a v0 sine theta square over 2g, right? Okay. Now let's see. We can see that, okay, if we put the square inside this, v square sine square theta over 2g. Okay. Check this is correct. Okay. You can see that g cancel. v0 square here cancel. This sine and this sine cancel. Okay, so we have, if we put these two to the left side and we put the cos to this side, so we have sine theta over cos theta is equal to 4. Sine theta is over cos theta is tan theta, so it means that tan theta theta equal to 4, or we have theta is equal to, using your calculator, is which is 75.96 degree. Okay, which give the solution of, if we round the number, so we can say that the solution is 75.96. Okay, 75.96. If we round the number, is 76 degree. Okay, so the answer is 4.